We've all seen a circuit from a macroscopic view. The components which make up a circuit are batteries, bulbs, and wires. We've learned the electrical components of current, voltage, and resistance. In order to elicit student concepts, we've included a somewhat simple circuit. We include a battery, a bulb, and wires to complete the circuit. So why does the light bulb light up?
There's like a circuit with a little light bulb and batteries. Like don't the electrons like bounce together almost to make the energy flow.
Electrons move from the battery through the light bulb back to the battery. Almost instantaneously.
Okay.
I think it might be a little bit longer, but not like much.
Yes, it'll take longer. Because electrons only travel at a certain speed, and this wire is longer than the other wire, and it's the same battery and same light bulb, so it's going to take longer.
What happened with the light bulb?
It's almost like, it lights up like almost as soon as I touch them together.
So would you change your answer?
I don't know. No?
So, do the lengths of the wire matter? Let's examine what's happening inside the wires from a microscopic view. If we were to cut open the wires and zoom in really close, what would we see? We know something is flowing inside the wire. Let's represent the flow as clouds for now. We know that electrons, which are a negative charge carrier, move through a wire. But what can we say about the path an individual charge takes? Although a wire may seem small compared to humans, electrons are minuscule by comparison. We know that there are electrons moving through the wire, but we don't know how quickly at this point in time. So our clouds that we used before will represent an arbitrary amount of charge. How fast does an electron travel in a copper wire in 1 second? We can use an ammeter to measure current, which is the charge in a time interval. If we do the math of charge over time, we get one crazy number of electrons per second. Current really tells us the charge per second that passes through a cross-sectional area of wire, which is a tiny sliver of that wire. So, if there are a set amount of electrons that move freely through the wire, only a certain amount of these electrons will pass through that small area per second. This implies the passage of charge through each part of the circuit is operating in the same way. We can then disregard the notion that charge has to get to the bulb from far away. If we calculate the electrons per second, we get a huge number. Let's compare this number to the number of electrons in the wire. Even though many electrons pass each point every second, there are more electrons residing in the wire. So many more that the velocity of a single electron is very slow. This is called drift velocity. But why is it moving so slow? You heard in the video, many people believe that electrons are pushing one another through the wire, much like our cloud representation shown previously. However, if we zoom in further, we will see that there are many electrons bumping into stationary nuclei. Let's look at this from another point of view. The nails on the board represent the stationary nuclei. If we drop a marble or an electron through this system, we can see that the path the electron takes is not straight through the wire. We saw that the marble collided with the nails, changing the direction of its path at small instances, much like an electron traveling through a wire and colliding with the nuclei. In the graph, we showed vertical position over time. This shows a somewhat constant vertical velocity, which is analogous to drift velocity. This is the Drude model. The beginning of our investigation focused on a small circuit and then extended the wires to make a longer loop with the same components. We tried to then analyze possible differences in the phenomena seen in the smaller circuit compared to the larger circuit. we found evidence that the bulb lit up in a similar time interval regardless of the length of wire. We learned that there are many electrons traveling per second in the small area of the wire. However, those electrons, they move at very slow speeds. Thanks for watching our video.